Just another example on circles from the higher course. I'll just read this out just in case you can't read my writing. So we've got 3 circles touch externally. You can see that from the sketch there. And it is just a sketch, so you're just going to have to imagine that those are perfect circles and not ovals as some of them look like. The centres are linear. All that means is the 3 centres lie on the same line. The equations of the 2 smaller circles are given below, so that's these 2 here. And the 2 smaller circles are congruent, and all that means is they are the same size. What we've got to do is find the equation of the larger circle, so that's the one obviously in the middle. Whenever you're being asked to find the equation of a circle, really what you're looking for is the centre and the radius. Once you've got that information, you can write down the equation quite easily. Even if you're not sure where to go or how to start this question, we have the equations of the 2 smaller circles. When we have the equation of a circle, we can find the centre and the radius. So that's always a good starting point. Okay, so again, just using the maths, this is given to you in the formula sheet, you don't need to remember it. 2g is the number in front of the x, so that's the x coefficient, so that's going to be 20 for the first equation. Dividing that by 2, I'm going to get g equals 10. And 2f is going to be negative 16, so dividing both sides by 2, we're going to get negative 8. So 2f is always the y coefficient in the equation. That means we've got a centre of negative 10, 8. So again, you take your g and your f, you multiply them by negative 1, and that gets you the x and the y coordinate of your centre. Okay, again, the next formula for the radius is g squared plus f squared take away c. Again, you're given that. You don't need to remember that. So 10 squared, add on negative 8 squared, take away c. And c is always this number at the end when it's in this format. So take away 139. Okay, so running through the maths then, we're going to have 100 plus 64 is 164. 164 minus 139 is going to give us 25. So we're going to have the square root of 25, which means that the radius of this circle is going to be 5. Now, I actually now know that the radius of both circles is going to be 5 because it tells you that it's congruent, okay? But I will do that calculation again almost as a check with the second circle. Okay, so starting off with the centre for the second circle, 2g, again we're looking for the x coefficient, negative 28. So we're going to get g equals negative 14. 2f is going to be the y coefficient, so 48. So we're going to have f as 24. And that means the centre, negative g, negative f, is going to be 14, negative 24. Once we've actually got the 2 centres, we can actually assign these to circles now. So by looking at the diagram, this centre here must be further to the right than this centre here. So if I just look at the x coordinates, this x coordinate here has to be bigger than this x coordinate here. So which coordinate or which set of coordinates has the biggest x coordinate? It's going to be the second one, which is 14, negative 24. And it's always a good idea to annotate your sketches if you can, which means the first one is negative 10, 8. That's backed up by the y coordinates as well. Obviously, this coordinate here is further down than this coordinate here, so this y coordinate has to be smaller than that y coordinate there, which is. Right, okay, so like I said, I will run through the radius calculation for the second circle, but we already know we should be getting 5, so we've done something wrong if we're not going to get 5, which can act like a kind of check. Okay, so we're going to have negative 14 squared, add on 24 squared. As I've said, you get this equation in your formula list. Take away c. Now in this format, c is the number at the end, so that's 747. Okay, so we get a radius of, and again, I'll just think this in the calculator and make sure it's correct. So I've got 14 squared, and I am adding on 24 squared, or negative 14 squared and 24 squared. Take away 747, and I'm getting 25 as I should. So it's the square root of 25, which is going to give me a radius of 5, as we already knew. Right, okay then, so what we're going to do then to get the centre and the radius of the bigger circle. Again, looking at the diagram, you might already see where this is going. Again, what I'll do is I'll just annotate it. We know that that's 5 there, and we know that that distance there is also 5, the radius of both the circle. Because these two circles are congruent, they're the same size, what that actually means is the centre of this bigger circle is actually going to be the midpoint between the other two centres. So to get the centre of the bigger circle, which is one of the things I need on my checklist to find the equation, I'm just going to find the midpoint. Okay, so midpoint formula, very simple. Add your x coordinates together and divide by 2. I'll write this out in full, but you don't necessarily have to. We've got a negative number involved over 2. And then we have add the y coordinates together and divide by 2 as well. So we're going to have a negative 24 add on 8 over 2. Okay, so the midpoint, which is actually, like I said, the centre of the bigger circle, is going to be 14 taken away 10 is 4, divided by 2 is 2, 24, negative 24 add 8 is negative 16, divided by 2 is negative 8. And again, we can check this in relation to the other two centres and just make sure we're roughly in the correct area. So this centre has to be further to the right than that centre there, but obviously not further to the right than that one there. It obviously has to sit in between these two x coordinates, which it does. And again, we can look at the y coordinates and do that rough kind of check as well. It's got to be lower down than the first centre and higher up than the second centre, and again, negative 8 fits that bill. So again, if you've got a sketch, if you've got a diagram, just make sure things tie in, the maths you're doing, tie in with the diagram before we crack on and answer the question. Right, okay, so that's good, that's one of the things in the checklist I want. The next thing I want is the radius. And again, you might already be seeing how we're going to get the radius. If I find the distance between these 2 points, that's going to give me that length there. If I take away the 2 radii, take away 10, that's going to get me the diameter of the bigger circle, and then obviously just half in that is going to get me the radius. So again, I'll just run through that, starting off with the distance formula, the difference between the x coordinates, so I'll use the second circle on the right hand side as my x2, take away, and the first coordinate is negative 10, so it's actually going to be add 10, add on, just Pythagoras' theorem as I've said, negative 24, take away 8, and again we're squaring that, and taking the square root, so the distance equals, okay, so we've got 34 squared, add on negative 32 squared. So let's see what that gives us. Not 34, sorry. Let's change that. It's 24, apologies, 24, not 34. Yeah, there we go. So 24 squared, add on negative 32 squared equals, taking our square root, we're getting 40. So again, the numbers are working out quite nicely here so far. We've got a distance between the 2 points as 40. Okay, so now, like I said, all I'm going to do is take away my 2 radii, which can take away 10, and then half my answer, and that'll get the radius. 40 minus 10 is going to give me 30. So the radius that I want is going to be 30 divided by 2, which is going to be 15. Okay, so I've got my radius, I've got my centre. I can plug into the basic format of the equation of a circle and get the equation. So remember, how does that work? Well, it's x minus the x coordinate of the centre, all squared, add on y minus the y coordinate of the centre, so take away negative 8, it's going to become add 8 equals 15 squared. What happens a lot in assessments is that pupils think, right, I've got my answer, brilliant, move on to the next question. Your final answer has to be in its simplest form. Now, you don't have to square out these brackets, but you do have to square the 15, so just be careful with that. Yeah, 225. Okay, and that's another wee example from the circle